Here we go. Let's do it.
It's time for Maths with Mr. Thomas.
Welcome to Chapter 10, Factorising. The factorising something that we did first of all in National 4 when we learned about taking out the highest common factor, but we're going to build on that. But before we build on it, here is just some revision from National 4. Check that you know this. So, what is factorising? Well, in the last chapter we were multiplying out brackets, so we know that 3 bracket x plus 2 became 3x add 6, because we did 3 times the x and 3 times the 2. And factorising reverses this process. So if we have 3x add 6, we go back to 3 bracket x add 2. We're putting it back into brackets. This is done by following one of 3 methods. So the first thing we always have to look for is what we did with National 4. It's the highest common factor, which is what this lesson is all about. This is revision from highest common factor. After that, in the lessons that we'll look at after this, there is what's known as a difference of 2 squares. We'd look for that after highest common factor. And the third thing we look for is trinomials, when we've got something x squared add something x add something. But as I said, this lesson is all about the highest common factor. So the first thing we have to look for whenever we factorise, it's true if there's a difference of 2 squares or trinomials, we've always, that's right, got to look for a highest common factor. If there is a highest common factor, that's what goes outside the brackets. And then you have to work out what goes back inside. It is best to show you with some examples. Hopefully, you remember this. So, if you have 2x add 6, what you're really doing is you're taking these numbers, the 2 and the 6, and you're thinking of factors of each of them. So if we think about factors of 2, you've got 1 times 2, so the factors are 1 and 2. If you think about the factors of 6, you would have 1 times 6, or you could have 2 times 3. The factor that they have in common, so if you're looking at the 1, the 2, and the 1, the 6, the 2, and the 3, the one that they have in common, the largest one they have in common is the 2. So that is why that is the highest common factor. Another way to think about it is you could say, what is the biggest times table that 2 and 6 are both in? They're both in the 2 times table. There is no higher times table that 2 and 6 are both in. So 2 would go outside the brackets. Then you need to think what goes inside the brackets, and that is done by taking the 2 and thinking 2 times what gives you 2x. Well, we've already got the 2, and it's the x that we're missing, so we can then put down the x. After that, we're going to be adding, so 2 times something gives us 6. 2 times what is 6? 3! It is 3, well done. So, you therefore put the 3. Lola, a question for you. How do you know that that is right?
You could multiply out the brackets in your noggin.
That's right, in your head you could just multiply out the brackets. So 2 times x gives you 2x, and 2 times 3 is 6. We started off with 2x add 6. That's what we get if we multiply out the brackets, so that there is the right answer. Well done, Lola. Woo! Harvey, next one. 4x take away 8. What is the highest common factor?
Is it 4?
It is, yes.
No, it's not. It's 2.
Ooh, Cammie's thinking it's 2. Is it 4 or is it 2? The 4 and the 8, they're both in the 4 times table and they're both in the 2 times table. They would also be in the 1 times table, but you never really use that because then you'd have 1 times 4x take away 8. It's just staying as it is. So, is it 2 or is it 4? Who wants to explain?
It's 4 because it's the highest common factor you want, not just the middle one or the smallest. That's just stupid.
You're right, it's the highest common factor, so it would be 4. Good. Again, if you think of factors of 4, you'd have 1 and 4, because 1 times 4 is 4. You'd also have 2. Well, 2 times 2 is 4, so you'd also have 2. So you've got 1, 4, and 2. And if you think of factors of 8, you'd have 1 and 8, because if you times them, they make 8. And also 2 and 4. The highest one is 4. 4 is a factor of both 4 and 8. So 4 times what is 4x? X. Good. And 4 times what is negative 8? Negative 2. Well done. Good. Again, Lola, what's the way of checking it?
Multiply it out.
Brilliant. Well done. And if you multiply that out in your head, 4 times x is 4x. 4 times negative 2 is negative 8. And that's what we have to factorise. So that is the right answer, as long as we've taken out the highest common factor, which we have. Okay, Cammy, what would you do for this one then?
Think about factors of 16. So 1 times 16, 2 times 8, or what else should you have? 4 times 4.
Good. So you could write them down if you want. And then factors of 24, you could do the same thing. You could start listing the factors. Or, as I keep saying, you could always think of the biggest times table both 16 and 24 are in. They're both in the 2 times table, yes. Yeah, they're both in the 4 times table as well. But the highest common factor, they are both in the 8 times table. Yes, 16 is in the 8 times table and 24 is in the 8 times table. There is no bigger times table that they both appear in. So 8 times what gives us 16x? That's right, it's 8 times 2. 8 times 2 is 16, but we've also got the x there as well, so we need 2x. And then 8 times what is 24? It is positive 3, so we've got a plus 3. Brilliant. And Cammy, how do you check that? Good, you multiply it out. So 8 times 2x is 16x. 8 times 3 is 24. That is right. So you have the right answer. Woo! Let's try some more. Factorise 10x, take away 15. Highest common factor. Anybody shout it out. 5! It is 5, yeah. The biggest times table at 10 and 15 they're in is the 5 times table. Or if you like to list the factors of 10, 1, 10, 2 and 5. And factors of 15, 1, 15, 3 and 5. 5 is the highest common factor. Then 5 times what gives us 10x? 2x. Good. And 5 times what gives us negative 15?
Negative 3.
Well done. How do you know that's right?
Multiply it out.
Good. So in your head you think 5 times 2x, that's 10x, and 5 times negative 3, it's negative 15. We are done. Next one, 12x add 6. The highest common factor is 6. It is indeed, yes. And 6 times what is 12x?
2x.
Good. And 6 times what is 6? 1. Brilliant. Well done. So you've got 6 bracket 2x plus 1. Well done. 56x take away 49.
Oh, that's harder.
It is. You could start writing down the factors of 56. You'd have 1 times 56, 2 times something, 3 times something, 4 times something, 5 times something. Just keep going through it, see what works. You could do the same with 49, or some of you may be able to tell the biggest times table that 56 and 49 are in is... Yes, Jess. It is 7. Brilliant. So then, Jess, you're thinking 7 times what is 56? X. Yeah, good. You've got the 8, so 7 times 8 gives you 56, but you've also got the x. Do not forget about your x. You've got to put the x in there as well. And if you do 7 times 8x, it's 56x. Then you think 7 times what is negative 49? It is negative 7. Well done. And again, the way to check it, in your head, you think 7 times 8x. Ooh, that's 56x. That's right. And 7 times negative 7. Ooh, negative 49. That's right. You've done it. Woo! Let's try some more examples. Example 3. Factorise 3x add 12y. Harley, hit me. The highest common factor is...
I think the biggest times table that both 3 and 12 are in is 3.
Good. So 3 is the highest common factor. And then you would have...
I think it's 3 times x to get 3x.
It is indeed good.
And then it's 3 times positive 4 to get positive 12.
Yes. Is there anything you're missing, Harley?
No.
Yes, there is. If you do 3 times 4, you get 12, but you've also got...
Why?
Well done. How do you know that's right, Harley?
I don't know.
Anybody help him out? Good. Just multiply it out. You do 3 times x and then 3 times 4y. And that will give you 3x add 12y. So you know that's the right answer. Good. Another one. 20a add 5b. Alan.
Is it? The highest common factor is 5?
It is indeed.
Then 5 times 4a is 20a.
Yes.
And 5 times... Well, 5 times 1 is 5, but if it's 1, you don't really need to write it.
Well, you would if there was nothing else, but you've also got a b. Yes, you need to put the B in as well. So you could write 1B or just B. Again, to check if you're right, what do? Multiply it out. Good. So 5 times 4A is 20A. 5 times B is 5B. That's what you started with. That's the right answer. Brilliant. Another one, 18C, take away 27D. What would you do for this? What is the biggest times table that both 18 and 27 are in? 3. They are both in the 3 times table. Is there something bigger? There is something bigger. Is it a million? No, it's not. It is 9. Good, it is 9. And then 9 times what is 18C? Good, 9 times 2 is 18, but you've also got the C. And 9 times what is negative 27D? Good, it's negative 3D. Well done. Again, multiply that out. Just check in your head that you get 18C, take away 27D. And you do. You're good. Well done. Another one. Example 4. Factorize. AB add AC. What you thinking?
Oh, there's no numbers here. This makes it so difficult. I'm so sad.
Well, don't be sad. It's not difficult. When it's the highest common factor, sometimes there isn't a number to take out as a highest common factor, but still they may have something in common. If you look at the AB and the AC, is there any letter that they have in common? Any letter that's the same, both here and here?
Oh, A! They've both got an A!
They do indeed, yes. So A is a common factor, so you could take out A as a common factor. And then you think A times what is AB? Well, AB means A times B, so we're doing A times B. A times B is AB. Good. Then plus, and A times what gives you AC? So again, A times C is AC, so that just means A times C. That's it. How do you know that's right? Good, you multiply it out. A times B is AB, A times C is AC. You've got the right answer. High five. Next one. GH. Take away G squared. Edmund, hit us with your knowledge. Poof, 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 poof. Good. G is a common factor because you have a G here and you've got a G squared here. Remember, G squared really means G times G. So we're getting rid of the G here and one of the G's here. So G times what is GH? Well, I've already got the G, but we're needing the H in as well. G times H would be GH. And G times what would be that G squared? Well, remember, we got rid of one of them, so we're just left with G. Or G squared means G times G, so it has to be G times G. And because it's negative G squared, we're also bringing that negative in. Again, once you get to that, multiply it out in your head. Good. 3x add 4xy. What you thinking? Highest common factor. Or is it 1? Number-wise, it would be yes, because you've got 3 and 4. So factors of 3 are 1 times 3. Factors of 4, you'd have 1 times 4 or 2 times 2. Number-wise, the highest common factor would be 1. But is there anything else that's the same? Well done. Nicely spotted. It is the x. So you could take out x as a common factor. You're really taking out the 1 as well, so you could have 1x if you want, but you just write that as x. And then x times what is 3x? Good, it is 3. And then we've got plus, and then x times what is 4xy? Remember, 4xy means 4 times x times y. We're already multiplying it by the x, but we've also got the 4 and the y, so we'd have 4y. And if you multiply that out, x times 3 would be 3x, if you just write the number first, and x times 4y would be 4. Again, put the number first, and then xy to put it in alphabetical order. So, you get back to the question, that's the answer. Example 5, factorize x squared add x. So, with this one, x squared means x times x. And we're adding on an x. So, with this one, if you take out a common factor, we'll have got an x here and an x here. So, that is something they have in common. So, you could take out this x and this x. You're taking that out and saying they both have the x as a common factor. If you get rid of them then, if you get rid of that x, you're still left with 1x. So it'll be x times 1x. And then plus, and then x times what gives you x? Well, that's like saying 7 times what is 7. Or 12 times what is 12. It's just 1. So you just write down 1.
Do you have to write the one?
Yes, you would, because if you don't write it, it would just be x times x, and there'd be nothing there, and x times x is x squared, but you also need that x, and that is x times 1 to get the x. Woo! Next one, x cubed, take away x squared. So x cubed means x times x times x, and then you're taking away the x squared, which means x times x. So what do they have in common? X. Good. So yes, there is an x here and an x here. That's something they have in common. Anything else?
Oh, another x.
Yeah, good. There's an x here and an x here. So we could think about taking those two x's and those two x's out as a common factor. So we put them outside the brackets. So in other words, x squared, because x times x is x squared. And then it's x squared times what gives us the x cubed? Well, we got rid of two of the x's and we've still got that other x. We need that. And x squared times x would be x cubed. X times x times x. X squared times what gives us negative x squared? You're right, we need the negative. Good. And x squared times what is x squared? Well, again, that's like saying 7 times what is 7? You're just multiplying it by 1. So let's just take away 1. Woo! And that's your answer. Next one, a squared b plus ab squared. Do not be afraid to just go to the side and think a squared means a times a, and you're also multiplying that by b. Then you're adding on, again, ab squared, that's an a times by the b squared, which is b times b. What do they have in common? Well, you can see there's an a there and an a there. Brilliant, so that's a common factor. Anything else? Well, yeah, good. There's a b there and a b there. Good. Another a? No, you couldn't take out another a because they do not have another a there. It's got to be something they have in common. So, we have taken out an a and a b from both parts, so ab is the common factor. If you get rid of that a, b, it leaves you with one a here. And again, if you get rid of the ab here, it leaves you with one b. So that is what you would have. And again, multiply that out. ab squared, well, a times a gives you a squared. You've also got the b. And then ab times b, well, you've got the a, but b times b would be the b squared. Example 6, factorize. So this time there are 3 terms. Do not let that freak you out. Why? Because it's the same thing that you're doing. You're still looking for the highest common factor, but instead of doing it with 2 terms, you're doing it with 3. So number-wise, you've got a 2, a 4, and a 6. 2, 4, 6, 8. Yes, thank you. What is the highest common factor? What's the biggest times table that 2, 4, and 6 are in? 2. It is indeed, yeah. They're all in the 2 times table. They're not all in the 3, the 4, the 5, the 6, 7, 8, 9. They're not all in that times table, mainly because of the 2. But you've got the 2 as the highest common factor. Then think 2 times what gives you 2 times a? Well, that's 2 times a. 2 times what gives you 4b? Well, it's 2 times 2 to get the 4. And you've also got, good, you're getting this, you've also got the b. And then 2 times what gives you 6c? Well, 2 times what is 6? 3. Good. And if you do 2 times 3, you get 6, but you've also got a c. Brilliant. And again, to multiply that out, 2 times 8, 2 times 2b, 2 times 3c. And yes, you would get back to your question that you've got to factorize. Brilliant. With b, 15p, take away 20q plus 100r.
Ooh, this one's a little trickier.
It is indeed, yes. Arafat, so what do you think you do?
I don't know.
Are you sure?
Okay, maybe I do. Do you look out for the highest common factor?
You do indeed, Arafat. And what would that be? You've got 15, 20 and 100. They are all divisible by what?
Is it 5?
It is indeed, yes. They're not all in the 10 times table because 15 is not in the 10 times table. They're not all divisible by 15. It would be 5. Again, you could go to the side and start listing your factors or think what's the biggest times table they are all in, but it would be 5. So 5 times what is 15p? Well, it's 5 times 3 that gives you 15, and you've also got the p. 5 times something is negative 20q. Well, 5 times 4 would give you 20, but you'd also need the negative, so negative 4. 5 times negative 4 is negative 20, but you also need q. Good. And then 5 times what is 100?
Is it 20?
R! Well done, you're just like a pirate. So 5 times 20r would be 100 r. Excellent. Next one, example 7. Factorise a squared add ab. Take away 7a.
Oh, I know this one. There's no number to take out, but I've noticed straight away you've got A's there, and A's there. You've got so many A's.
You do. So what could you do?
Take it out as a common factor.
Good. So a times by... Hang on. Before we get to that, is there anything else you can take out as a common factor? No, he's got a b here, but you don't have b's there. Number-wise, you got 7, but you don't have numbers here. So yeah, it is just a. A times what is a squared? In other words, a times what is a times a? Good, it has to be a times a, yeah. A times what is a times b? Well, a times b is a times b. And a times what is negative 7 times by a? Well, we've got the a, we just need the negative 7. Brilliant. And again, you could check that by just multiplying out your brackets.
Yes, you can.
This one, 4m, take away m cubed, add mn. With this one, what do you notice?
Well, I notice that there's an M and an M and another M and so many M's.
There are so many m's. Yeah, you've got an m here, you've got m's here, and you've got an m here. Remember, m cubed means m times m times m. So if we're taking out an m as a common factor, we're taking out an m from there, take out an m from there, take out an m from there. So we're taking out m as a common factor. Number-wise, there's a 4 there, but no other numbers. There's an n there, but there's no other n, so they don't have anything else in common, so it is just m. So bracket. M times what is 4m? Well, if we've taken out the m, we're just left with that 4. With the m cubed, we need that negative to give us negative something. And if we take out that m, we're still left with an m times m. Or in other words, an m squared. And just think m times m squared would be that m cubed. So we can get back to what we had originally. Then plus an m times what is mn? Well, we took out the m, so we're just missing the n. You got it. Well done. That's your answer. Example 8, factorise. 6ab add 9b add 15b squared. If you can do these ones, you can pretty much do any of them with the highest common factor. So number-wise, with 6, 9 and 15, what is the biggest times table? They are all in. That's right, it is the 3 times table. So we've got 3. Anything else they have in common? Good, yeah, you've got a b there. You've got a b there, and you've got a b squared here. Remember, b squared means b times b. So we're taking out a b there, taking out a b there, and we're also taking out a b there. Then, number-wise, 3 times what is 6? Good, it's a 2. We've also got the b. We've taken that out as a common factor, and it leaves us just with an a there. ab would be the ab. 3 times what is 9? Good, it is going to be 3. And letter-wise, we've taken out the b. There's no other letters, so it just stays as 3. And then 3 times what is 15? It is going to be 5. Good. We've taken out a b, but remember, b squared means b times b. There are 2 of them. So we would have, if we take one of them out, a b remaining. And again, b times b would give you the b squared. With these ones, again, especially check that you are getting these. 3b times 2a. Number-wise, 3 times 2 is 6. You've also got the b times a, or a times b, doesn't matter which way around you have it. 3 times 3 is 9, and you'd also have the b. 3 times 5 is 15, and b times b is b squared. Similarly with this one, with example b, 60gh squared add 10h squared, take away 20h squared j. Number-wise, first of all, what is the highest common factor? What's the biggest times table? It's 60, 10, and 20 are in. Good, they're all in the 10 times table. Letter-wise, is there anything that is here, and here, and here you could take out? Yeah, brilliant. You've got an h squared. You can see you've got an h squared there. You've got an h squared there, and you've got an h squared there. So you can take out h squared. Make sure it's not just h you're taking out. It is h squared. You need the highest common factor. You need to take out the most that you can. If you take that out, then you're thinking 10 times what is 60? Well, it is 6. H squared, you've taken that out as a common factor, and you're left with the g. 10 times what is 10? It is just 1. Good. You don't really need to write that unless it's the only thing you have. You've taken out the h squared. Well, it is the only thing that you have then with the 10, so you'd have plus 1. And that way it's 10h squared times 1 would give you that 10h squared. And then they've got the negative, so it's the 10 times negative 2 to get negative 20. And you've taken out the h squared, but you're also needing that j in there as well. What do you do once you get to that step? Multiply it out to check. You do indeed. Well done. And with this one, example 9, same as before, if you can factorise these, you will be absolutely fine with any factorising questions. 54, 9 and 27, the biggest times table they are all in is 9. It is good. Number-wise, it is 9. Letter-wise, you've got an a squared here, and an a squared here, and an a squared here. Anything else that you have here, here, and here? No, so it's just going to be 9a squared as your highest common factor. Number-wise, 9 times what is 54? It is 6. You've taken out the a squared, so you still need a b squared. 9 times what is 9? It is just 1. Again, you don't need it unless it's the only thing that you have. A squared, you've taken that out as a common factor, but we've still got a b here, so we have to write that down. So we don't need to write down the 1 because b is there. And then 9 times what is negative 27? Good, it's negative 3. We've taken out the a squared, there's nothing else there then, so we just close the bracket and multiply it in our head to check that that is our question. And the last one, who is up for doing this last one? Okay, Finlay, what do you think number-wise? Is there anything you could take out as a highest common factor? 7? Good. They're all in the 7 times table. Again, go to the side and write down your factors if you want. 14, you'd have 1 and 14. 2 times 7, because if you multiply 1 times 14 or 2 times 7, they make 14. 35, you could do the same thing. You could do 1 times 35, and so on. And with 77, 1 times 77, 2 times 3 times 4 times, just write down what would work. 7 is the highest common factor. But is there any letters you could take out as well? Yeah, you've got an r here. You've got an r squared. R squared would be r times r. And you're taking out one of them. Again, you've got an r squared, so you've got an r times r, and it would just be one of them that you'd be taking out. There's an s here, but there's no s here, so you couldn't take that out. T here, well, yes, there's a t here, so you can take out that as a common factor. T squared would be the t times t. So you can take out one of them as a common factor, and again you can take out that t as well. So, which means then you've taken out the r and the t, so you'd have 7 RT as the highest common factor. After that, 7 times what is 14? Well, it is going to be 2. You've taken out the r and the t, so you're left with s, so we need 2s. 7 times what is negative 35? Good, it's negative 5. And then with the r and the t gone, well, you're still left with an r and a t, so you'd have an RT, because r times r we give r squared, t times t we give t squared. And then plus, and 7 times what? 77? 11. Well done. You've got the r, you've taken out one of them, so you've still got an r, because you need r times r to get r squared. S, you've also got that there as well, and t, we took that out as a common factor. So that there, 7RT bracket 2s, take away 5RT plus 11RS. Is your answer. Woo! As I said, if you can do these ones, you can do any of the ones with highest common factor. Well done! High five to you. If you're looking for some questions to try with the highest common factor, there's a page in the National 5 TJ book, page 65, exercise 7.1, or the best resource, to be honest, for this is probably the Zeta book. If you look at the Zeta National 5 book, there's 3 exercises. It splits this up. So you've got exercise 6.1, 6.2 and 6.3. They all deal with the highest common factor. It's pages 38 to 39. And check your answers with Zeta or TJ or whatever you're using as well. Make sure that you are managing it. Woo! Was that fun? Oh, I loved it! Can we do more factorising? We will in a minute. Here's the next video. Woo!